Question 4 asks us to solve the following equations, finding exact solutions. I just copied the first of those equations below, which is 2x cubed plus 3x squared minus 2x minus 3 equals 0. So I'm going to rewrite what we have here. It's 2x minus 3 equals 0. And so what we can do with this one is we can follow the general steps for factoring polynomials, which would be to use the rational root theorem, find out what our test values are, and see where, for which test value our function is equal to 0, and that way we can find a factor. But in this case, actually, there's an easier way of doing it, and that's by factoring by grouping. So if we look at what we have here, we can see that we can get a 2x plus 3 from these first two terms, and a 2x plus 3 from the second two terms. And that's going to be a simpler and quicker way to factor this. To get 2x plus 3 from the first two terms, we want to factor out an x squared just from the first two terms. So factoring out x squared from this leaves us with 2x. Factoring out x squared from this term leaves us with a 3. In this case, for these two terms, we want to factor out a -1. So that leaves us with 2x here and a plus 3 as well. So that's great. Now we have a 2x plus 3 in both of these terms. So I'm going to bring that out to the front. And basically factoring that out of these two terms leaves us with x squared minus 1 here. And we want to factor this x squared minus 1 even further, and we can do that by recognizing that that's a difference of squares. So factoring that out will give us x plus 1 times x minus 1 for a difference of squares. And so now we have all our terms, or we have that whole side factored. And so to solve this equation, to find the solutions, we want to know what x equals to make this whole thing equal to 0. So to make this side equal to 0, any one of these terms can be equal to 0. And so if we take this first term and we say 2x plus 3 is equal to 0, subtract 3 on both sides, left with 2x equals -3, divided by 2 gives us x is equal to -3 over 2. And so if x is equal to -3 over 2, that makes this equal to 0, and that's a possible solution for x. We have to take these two into account, so x plus 1 could be equal to 0, which means that x is equal to -1 is another solution. For this last term, we have x minus 1 is equal to 0, which means that x equals 1 is another possible solution. So x is equal to -3 over 2, x is equal to -1, or x is equal to 1 are the three solutions to this first equation in question 4. So the next equation in question 4 is 3x cubed minus 2x squared minus 7x minus 2 equals 0. So in this case, we want to start by doing the rational root theorem, and so to do that, we need to find our test values, and we get our test values by first finding the variables q and r. So if we remember, the variable q is going to be factors of the constant in our equation. So in this case, our constant is the term without x. And so in this case, it's going to be -2. And r can be factors of the leading coefficient, which in this case, our leading coefficient is 3, so these are going to be factors of 3. So let's think of what our possible values for Q and R are. So factors of 2 are going to be plus or minus 1 and plus or minus 2. Factors of R, factors of 3 are going to be plus or minus 1 and plus or minus 3. And so our test values are going to be all combinations of Q over R. So those are going to be plus or minus, I'm going to start with everything over this value for R, so 1 over 1, plus or minus 2 over 1, but also plus or minus 1 over 3, plus or minus 2 over 3. Okay, and we can simplify these values down a little bit. So this is going to be plus or minus 1, plus or minus 2, plus or minus 1/3, plus or minus 2/3. Okay, so if we remember, these test values are the ones we want to plug into for x in our function of p of x to find out when that equals 0, because that's going to tell us what is a factor of our equation. So if our function is p of x equals 3x cubed minus 2x squared minus 7x minus 2, we want to start plugging these numbers in and see when this equals 0. So let's try p of 1. Plugging that in is going to be 3 minus 2 minus 7 minus 2. Evaluating that out gives us -8, so not 0, so that's not the right one. But let's try p of -1. So a -1 cubed is going to be -1, so that's going to be a -3. -1 squared is +1, so that stays -2. -1 times -7 is +7. We have a -2. And a -3 minus 2 plus 7 minus 2 is going to be 0. So if p of -1 equals 0, that means that x plus 1 is a factor of our equation. And that's because the rule is p of n is 0, then x minus n is a factor. So those negatives cancel out when we get x plus 1 as a factor in this case. So now that we know x plus 1 is a factor of this expression, what we can do is some long division to find out what we're left with once we factor this out of our polynomial. So what I'm doing here is dividing our polynomial 3x cubed minus 2x squared minus 7x minus 2 and dividing it by x plus 1. Okay, so the first thing we want to do is figure out what we need to multiply by x to get 3x cubed, and that is going to be 3x squared times x is 3x cubed. So we put that above the term with the same power of x. So now we multiply this in. 3x squared times x is 3x cubed. 3x squared times 1 is going to be 3x squared. And now we subtract those out, so that's going to cancel. -2x squared minus 3x squared is -5x squared. We pull down, sorry, that should be an x. We pull down -7x and do the same thing. So what times x is going to be -5x squared? That's -5x. -5x times x is -5x squared. -5x times 1 is -5x. Again, we subtract, those cancel out. -7x minus 5x is -2x. Okay, pull down this -2. And to get -2x, what do we multiply by x? We multiply a -2. So -2 times x is negative 2x. Negative 2 times 1 is negative 2. We subtract this out, we get 0, which means that x plus 1 is for sure a factor of this polynomial, because we should get a remainder of 0 if it is a factor. So that can make us confident. And so what we're left with now, we started out with 3x cubed minus 2x squared minus 7x minus 2 equals 0. And we said that x plus 1 is a factor. And when we factor that out, what we're left with is this on top. So 3x squared minus 5x minus 2. And so we want to factor this polynomial further. And to do that, you can either plug in your coefficients a, b, and c into the quadratic formula, and that'll give you the roots of this polynomial. Or you can just maybe see that what we're trying to get here when we factor it out is something that multiplies to negative 2 and adds to plus 5. And so that ends up being plus 1 and minus 2 in these brackets, because if we FOIL this out, we will get a negative 2 from these two terms. This will give us a negative 6x plus 1x, which is a negative 5x. So that's factoring out that side, and now we have this side all factored out, and we can figure out the solutions for this. So we want to figure out where each of these terms is equal to 0. What is x equal to make each term equal to 0? So if this term is equal to 0, x is equal to negative 1. So that's one solution. To make this term equal to 0, x is equal to negative 1 over 3. And to make this term equal to 0, x has to be equal to 2. So those are the three solutions for this equation in question 4. So the last equation in question 4 is this one, 3x cubed plus 11x squared minus 18x plus 8 equals 0. And for this one, again, what we want to do is use the rational root theorem. So again, what we're doing is finding what q and r, the possible values for q and r are. So q is going to be all factors of 8, which is our constant. And r is going to be all factors of our leading coefficient, which is 3. So if we think about the values for q that are possible, we have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. For r, it's the factors of 3, so plus or minus 1 and plus or minus 3 are our options. So now we want to think about what our test values are. And these are going to be q over r. And so combining these two sets, what we have is, I'm going to put everything over this value for r first, so plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 8 over 1. Now all over 3, so we have plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 4 over 3, and plus or minus 8 over 3. And so these values can be simplified down a bit. We do that, we get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and these all stay the same. All right, so this is quite a big set of test values, but we know that one of these will give us, or should give us, a factor of this equation. So testing them out, what we're going to be doing is taking our function p of x equals 3x cubed plus 11x squared plus 18x plus 8, plugging in these for x and finding out when this equals 0. We can see that some of them won't work out, such as +1 or +2 even, because that will give us all positive values here, and we're going to just be adding them all up. We're never going to get 0 that way. If we test all these out, what ends up working is p of -2/3. That ends up being 0, but let's just show that this does in fact equal 0. So when we plug in -2/3 for x, what we get is 3 times -2/3 cubed plus 11 times -2/3 squared plus 18 times 2/3 plus 8. Whoops, sorry, that should be an 8. Right? Okay, so putting this cubed into the top and bottom of this fraction, -2 cubed is -8, 3 cubed is 27. Putting the squared in, -2 squared is 4, 3 squared is 9. 18 times 2 is 36. We have 36/3 here, plus 8. Multiplying this 3 in gives us -24/27. 11 times 4 is 44/9, minus 36/3 plus 8. So to add all these up, we want to have a common denominator. So I'm going to make it all 27. So I'm going to leave this first one as -24/27. To make the bottom 27, we multiply it by 3. So multiplying 44 by 3 is 132/27. Multiply top and bottom by 9 in this case, so 36 times 9 is 324. 27, and 8 times 27 is 216. 27. So adding up -24, +132, -324, +216 is 0. So perfect, this works out. And what this tells us is we know that if P of Q over R, or a test value, equals 0, then that means that Rx minus Q is a factor of our function. So in this case, what we know that a factor has to be R, so 3x minus a -2, so +2. So this is one of our factors. And to find the other ones, what we want to do is some long division. So we're going to be finding out what's left when we factor out 3x plus 2. So I'm dividing our function, our equation, 3x cubed plus 11x squared plus 18x plus 8. Dividing that by 3x plus 2. So to get 3x cubed, we multiply 3x by x squared. X squared times 3x is 3x cubed. X squared times 2 is plus 2x squared. Subtracting that, this cancels out. 11x squared minus 2x squared is 9x squared. Pull down a plus 18x. To get 9x squared, we multiply 3x by 3x. 3x times 3x is 9x squared. 3x times 2 is plus 6x. Subtracting that cancels. 18x minus 6x is 12x. Pull down a plus 8. Get 12x, we multiply 3x by 4. 4 times 3x is 12x. 4 times 2 is 8. So when we subtract that out, we get 0. So great, 3x squared is indeed a factor. And so if we look at what we're left with, what we have, we started out with 3x cubed plus 11x squared plus 18x plus 8 equals 0. And when we factor out 3x plus 2, what we're left with is this thing on top, which is x squared plus 3x plus 4. That equals 0. And so of course we want to factor out this section some more to figure out what solutions we get from that. And to do that, we want to use the quadratic formula. So what we're trying to factor is x squared plus 3x plus 4. And the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac over 2a. So we plug in a, b, and c, which are the coefficients of what we're trying to factor. So b is 3 here, and so that gives us negative 3 plus or minus 3 squared minus 4 times a, which is 1, times c, which is 4, over 2 times a, which is 1. So evaluating this out, we get 3 squared, which is 9, minus 4 times 1 times 4, which is 16, over 2. And so we can see that we have a problem here because 9 minus 16 ends up being negative 7. So what we have is a square root of a negative number, and that doesn't give us a real answer, but we can come up with imaginary an answer that has an imaginary number in it. So using I to solve this, and the way we do that is we know that I is defined as the square root of negative 1. So under the square root sign, we can say we are multiplying a positive 7 times I squared, because I squared is going to be negative 1. And that's all over 2. So we can bring this, or we can take the square root of this I squared, and that's just going to be an I on the outside, and we're left with a square root of positive 7 over 2. And in this case, we can go to our two options with our plus or minus here. So what we have is x equals negative 3 plus I times root 7 over 2. And x is equal to negative 3 minus I times the square root of 7 over 2. And so those are the two solutions from this side of our equation. But if we remember that we also had what we factored out, which was 3x plus 2. So if this term is equal to 0, we do get a real answer, and this gives us that x is equal to negative 2 over 3. So those three are our solutions for this last equation in question 4.